Hello everyone. Today we are going to solve a new problem, combination sum. Given an array of distinct integers, candidates, and a target integer, return a list of all unique combination of candidates where the chosen number sum to target. You may return the combination in any order. And we are given an example. This is candidates array 2, 3, 6, 7, and target is 7. And the output is just two arrays. First is 2, 2, and 3, and second is 7. It is mentioned that the same number may be chosen from candidate unlimited number of times. Let's understand this problem with an example. 2, 3, 6, 7. So if 2, 3, 6, 7 is our array and target number is 7, what all what are all the different kind of sub arrays, or the items which we can pick from this array which can sum up to this number? So in this case we can just pick, the first option is just pick one number, that is 7. 7 is equal to 7, so we are good. The second option can be we pick 2 two times and 3 one times, right? So the thing is we can pick one element, one item, indefinite number of times, unlimited number of times. Okay, so the question is we have to basically return a list of items. So this is our first list, this is our second list, all the possible lists where in every list all the numbers should sum up to this this target. So in our case we will have to return a list where the first uh, option is 7, second is 2, 2, 3, right? So this is list that has two items and this is the result. Okay, so let's first understand something. There's a pattern here. The pattern is we have an array and we have to walk through this array. Now if we just have to walk through this array once, right, just simple, go to 2, then jump to 3, go to 6, then 7, up to so on, then a normal for loop, a normal iteration is more than sufficient for it. Here we are doing something interesting. We have to, let's say, walk to this first item and we can keep on jumping to the same item again and again. We have to keep on picking the same item again and again, just like this scenario where we picked 2, the first item, 2 times, and then we jump to the next item. So when we have to just walk through this array linearly, we have linear iteration approach. That is also called simple for loop. Basically, int I is equal to 0, I is less than length of the array I plus plus. In this case where we have to play around, we have to not just walk through the array, we have to dance around the different indexes. That is where uh, recursion helps. So for example, just like how we are doing here, we can grab any number, unlimited number of times, and we have to jump through the same index. We can think of few other scenarios. For example, grab all the permutations, right, all the different subsequences which we can create from the array, right? So if let's say we have 2, 3, and 6, for example, we can have 2 as first option. We can just pick the first subsequence. Second is 3, third is 6. Then we can maybe pick 2, 3, 2, 6, 3, 6, and then 2, 3, 6, right? All the different ways, all the different subsequences that can be created from this array. For all of these type of questions where this one, the result, the subsequence, all the different possible subsequence, it is kind of like we stand here, we grab this number. We have two options: we either grab this number or we do not. So what we have to do is, roughly, we have to get to an index, we have to create one state in the recursion where we grab this index, the value on this index, and the second branch would be we do not pick this index. So we, in this current state, we create two branches and then we keep on creating those many states. So the overall we have to walk through this array using recursion, and let's see if we can solve this problem. Okay, So here what I'll do is I'll get to this first position 2. Then our first recursion state is 2. I'll stand at 2. Then I'll have two options. First is I can grab 2 and consider that as the first contender of the list, and the second option is I just ignore this value, right? So the first option is I pick this value, and if I pick this value, there's a possibility that we might have to use the same number again. So what I'll do is I'll say, okay, let's say this is my list, processing list. So I'll say in this processing list, I'm going to pick 2 and I'm going to stay here. So the first branch is stay here, stay at the same point. Second position would be move ahead. So I'll say I can pick this item and I can continue to stay here. I can pick this item, I move ahead to 3, the next index. So if we stay here, again we can create two states, stay here or move ahead, right? If we move ahead, then we go with 3. Now the thing is, let's make it more precise, these states. So when we are moving ahead, we are ignoring the current item. Okay, so if this is the list, the contender list, so when we stay here and move ahead like this, we are saying we have to create a list where we grab 2. Currently we just have 2. When we move ahead, we do not pick the current item, so there is nothing in this list. We just move ahead. So I'm saying we'll have nothing, it is just empty array. Then when we are here, we can stay here, that means we pick number 2 again. So we are saying it is going to look something like this, and if we move ahead, we ignore the current item, then we just push the same list here, we do not grab the current item. Then again we stay here, that means we are going to grab this number and going to stay here, otherwise we move ahead, we ignore 3. In this way we kind of create this flow, this process where we can have the same we stand at an index and we can keep on grabbing that index indefinite number of times, and we can keep on checking, okay, the list created till now, is it summing up to the target? Whenever we find that at any given point in time we've got to a state where we've got 2, 2 and 3. So in this state, when we'll get 2, 2 and 3, we've got 2, 2, we have to ignore this state, so we've reached here and we have to grab it. So actually the state here was okay, we pick 2, we pick 2 again, so we reach here, then we ignore 2, we have to ignore 2, so we get to number 3, and then we pick 3. So at this point we are going to get 2, 2 and 3. Let me explain with code, it will be easier. Okay, so we have this input array, we have this target, and we have to create a list of list. Sure, so let's list of this is our result set, which we are going to return at the end. Okay, and we are saying we will be creating a recursion private. For now, let's not think about what we are going to return. We might have to just walk through it, pass a list, and because list by default will have the flow of reference based passing, that means yeah, it is going to maintain its value, its state, because we are just passing pointer. We'll say private void walk through array, it will represent the current state. For example, when we are here, it is I is equal to 0, it is I is equal to 0, it is I is equal to 1, something like that. So what is the current state where we are at? Then it will help if we do sum till. Now as we keep on adding items in the list, we have to keep a track of what is the sum in the list, otherwise we would have to just grab the list and keep on adding the numbers and calculate the sum till now again and again. We'll just keep sum till now. What's next? Okay, we have to create candidate list. We have to keep this with us. Candidate, why we are calling it candidate list? Because although we are keeping the flow of items till now, but we are not sure whether it is going to add up to target. If it adds up to target, well, that is one of it is going to work as one of the list in the result. If it does not, we are just going to ignore it. Okay, and final thing would be we will keep on passing our result whenever we'll keep on checking if the current candidate sum is equal to target. If it is, we'll keep on adding it in this list. So I list of result, sure. And as I was saying, we'll have two states. First is we stay where we are not going to go ahead. So if we were at index, we are going to stay at index. And because we stayed here, the sum till now is not going to change. Okay, my bad. If we are going to stay at the same index, we do assume that we are going to grab the current value as well, right? So my bad, we are going to add the current. Okay, let me pass the candidate array. I'll just call it ARR. We have ARR, the current index. So we have added the sum, we stayed here. In the candidate list, we have to add that the current number candidate list, because when we moved from 2, we're following this state. We have moved from 2 and stayed at 2. We are going to add this 2 in our list. So candidate list dot add the current number, that is ARR of I. What's next? Then we'll just pass the result. So this is first scenario, and the second one is we go ahead, we move to the next index, and in that case we are not going to add the current array in the candidate list. So we'll just pass the candidate list as it is, result as it is. Let's add terminating condition for the recursion. For this recursion, we'll say if sum till now is equal to target, so we would have to pass target. If it is equal to target, there we go, we have candidate list, sorry, result is our final result dot add candidate list. I'm making few mistakes, but we are going to sort this. We're going to fix those things at the end. Else, if sum till now is greater than target, now we know based on the constraints that the number is always going to be positive and the length is till 30. So if the size of the array is small, the probability is quite high that a normal recursion without even thinking about the optimizations is going to work. And because it is positive, we know that if we have crossed the candidate sum has crossed sum till the target, if the sum of the candidate means sum till now, if sum till now has crossed target, we will never get it back to target, because if the sum till now is 15, our target was 10, we are not going to find a minus 5, so that 15 minus 5 is 10, right? So we'll just say if sum till now is greater than target, we're just going to return. And if we've again reached to the target, there's no point in going ahead. We're going to return. And there will be one more scenario when we would like to return, and that is if we have walked through the array to the end is greater than equal to array.length. Okay, so we have created our terminating conditions, we have created two states, fine. Let us call this walk through array. This is our candidate. Our initial index is going to be 1. Sum till now is going to be 1. Candidate list, we can create candidate list is new list of int. We can pass this here and we'll pass result and target. So our call is ready, and finally at the end we have to return just the result. Now, few problems here. First is how we are dealing with this list of list. Second is how we are dealing with this list. The thing is, let me clean this up and let me explain how call by reference. There are two things: call by value, call by reference. So works. So if we are at, let's say, first state, right, we had this array 2, what was that, 2 3 6 7, 2 3 6 7. Initially we were at I is equal to 0, 2. Then we said we are going to stay here, 2. Next we said the second option was we are going to move to the next index, 3. Next option was we are going to stay here, 2. The next option was we are going to go ahead, 3. Here again we stay here, 3. We are going to go ahead, 6. Here stay here, 2. Go ahead, 3. Stay here, 3. Go ahead, 6. Stay here, 3. Go ahead, 6. Right, something like that is happening. Now the thing is, if we create, you'll see that we have a list of candidate, and whenever we are picking the current item, so we decided the rule was when we stay at the same index, we are going to grab the current value and keep it in a candidate list as well, which we have done here. There you go. Right, so let's say we have this candidate list, because we just created one instance of candidate list which we are just pushing and across all the different states. So in this list, initially at this point, the recursion is going to go to the first, going to go to this state, and as it moves to the left state, we are going to add our first number in the list. Now it goes to again this state. We are going to keep the current number here. It again goes to this state, and remember the target is 7. We are going to keep number here, right? So wait, I think I've made one mistake. Like, this is our first state, and during this state we add this number and pass it. Then this state, this number is added. This state, this number is added and passed to next one. And finally we are at this state, we add this number and we pass it to the next one too. Here we will 2 4 6 8, because we are at 8. It will see that sum till now is greater than target, and it is just going to return from there. So it is just going to return from there. Okay, okay, sure. Now the thing is, if we return from something, we would have to remove that item from the list as well. Why? Because we'll say, so we return from here, and we would want this 2 which was added to be removed from the list, so that if we are going to the right, my bad, I'm going to minimize this, and something has happened here. Okay, better, sorry. As I was saying, we have this 2, okay, we have this when we moved back, we have to remove this number 2. So our list, which used to look like 2 2 2 2, we have to remove this 2 so that it can go to the right to the next item 3, and it can replace this 2 by 3, right? We still are going to see 2 plus 2 plus 2, 6 plus 3, 9 is going to be greater, and it is still going to come back, and then it is going to come back, right? So once it comes back, we need to remove this item. So basically, when we understand that this the current item, current value, can be considered as can contribute to the final candidate list, then we are saying we are going to add it. But when we are sure that it is definitely going to be useless, we need to remove it from the list so that we can add a new candidate item. So for that, because recursion is basically stack based, that means you just move from here to here. So just like how we have added it, the first item gets added, then the second item, so whichever we are processing, it is going to stay at the top of the stack. Okay, so that means if we are thinking of this as a flow in the list, the last item in the list is going to be the current state where we are processing it. So when we come back from recursion, all we have to do is to remove the last item from the list. That means instead of doing just this one, candidate list item dot array, okay, we'll make it cleaner. So we are saying we add it in the candidate list, and then we remove the last item, candidate list dot remove at candidate list dot count minus, we will remove the last item, because based on the current state, assuming that whatever happened in this recursion function, we already have cleaned the list, if because it was not useful and all that, um, candidate list. So when we reach back, when we process the complete function, execution is back to line number 25, then we are assuming that we are back to our candidate list with this array of I at the top. Okay, sure. So in this way, candidate list stays clean. Now we have a new problem. We are just adding this candidate list in the memory. Okay, so candidate list is a pointer which is pointing to a memory, and we have result which is again a pointer pointing to a memory of list of list. So we are saying in this list of list, we keep on adding the same pointer candidate list, and because of which, as candidate list keeps on changing, few candidates will add, few candidates will remove. But even if we have, let's say in the first index we found sum till now is equal to target, we added a candidate list, later candidate list will get altered, and with that, even the first item which we added in the result is going to get altered. Okay, it is not going to stay the same when we reach to that state where sum till now was equal to target. So all we have to do is create a new list, um, actual. So we'll say target candidate list is new list of int, and we pass this list. So a new memory location is going to be created, and we are creating a new pointer, so it is all new stuff, and then we add this candidate list to this result. Now although the result pointer needs to stay the same, that's okay, but then target candidate list, we always create a fresh new list, so everything stays cool and nice. Okay, so the structure looks nice, looks great. Now let's run this. A problem int array index sum till now list of int list of I list of int target. Line number 11, I've made some syntax error here. Int array int list of int candidate list of I list of, okay, this should be list of I list of int and target. Okay, better. That syntax error has been resolved now. Line number 24, it says the name I because I is index here. So we have to add index, 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 index. There's no argument requirement. Now we'll just double check. The first is array. We have to pass array. Then we pass index, then some till now, candidate, result. We have to pass target as well. Target. Okay, it has passed all the three test cases. Let's submit this and see if all the test cases are passed. There we go. Our solution has been accepted. Our runtime is good. Memory is good. Cool. So we have solved this problem. Combination sum. Thank you.